So before we talk about combining, I just want to illustrate a point for you. This is a pitfall, something that one of those things, it's a minor annoyance, but you got to do it. So we're going to take a look at two different graphs here. If you have a graphing calculator, you can pull them out. I'll get one out to show you as well. I'm going to compare x squared and this 2x minus 2 squared. So what I want you to think about is there's two transformations in there, right? I'm playing around with x, like 2 times x, and I'm also doing a minus 2. So think about, what would you guess? You don't have to say it, but what would you guess is going to happen? Think about your prediction, okay? And then we're going to see what happens when we actually graph it. Okay, so I don't want to ruin the suspense if you don't have your calculator, or I'm about to hit the enter key, and that's going to give us the new graph. What do you think is going to happen to it?
It's going to move right and stretch horizontally by 1/2.
Right, so a horizontal stretch factor is a half. It's going to make this graph skinnier, and we're going to move to the right by 2. Let's see what happens. Skinnier, is that right? Did we make the right call?
Yeah.
Did it move to the right by 2? Really? Well, it's the scale is not up to me on this graph. But if you look, that's actually one. Each tick mark is a half, but it actually moved over 1 unit. See, that's a 1 there. 2 would be all the way over here if it moved 2 to the right. So it only moved by 1. Does anybody want to offer up a reasonable explanation? If you have the notes in front of you, you can probably cheat and look ahead a little. Tony, yeah?
Oh, because the B is supposed to be outside the bracket, so...
Yeah, it's going to need to be factored, okay? So this is just one of those housekeeping items that before you start talking about combining them, it's way easier to think about this graph. It's horizontal shift of 1 unit to the right and a horizontal stretch of a half. So the way we want to think about it is not the way it appears, but in factored form. We'd like to think of this as it's a subtle difference, but it will make your life that much easier, right? If there's one careless mistake that could pop up at you, that's it. Okay? So be careful with it. Again, I'll just let you take a look. Here's the two graphs. It didn't happen with 2 to the right. It was only 1. Okay. So now that you've got factoring out of the way, remember to factor. This is a handy little acronym for you. You can move these letters around carefully, but basically you can't make a nice word. It's not even a real word that I'm giving you, but this is the one that students tend to remember. It helps. Rect. That's the best I could do. It's reflections, expansions, compressions, translations. If you think about it, what I'm saying is you need to do multiplications before you do additions. But visually, when you look at your graph, it's easier if you take it one step in the transformation at a time. So each of those, in that order, will give you the correct graph when we're done. Okay. So this is the part that matters. If you didn't print your notes today, this is the part that matters. I want to actually see that you can use these ideas of pulling apart the transformation and saying it in order. So right now, if you look at this is the reflections, this is expansions, compressions, and this part here is the translations. So I've just laid out the table so that you can see it happen in the order it's supposed to. Okay, so tell me what happens to the first graph. First thing we're looking at is reflections. What reflection happened to this graph here? Good. X-axis happened. So if I'm to describe it in the proper order, I could tell you first to do a reflection in the x-axis. Vertical stretch factor, what do you think? Does this graph get stretched or shrunk at all vertically? Yeah-ish, no. Yeah-ish, no, we will accept. That answer is correct. Somewhere in there, I guess. No, there is no vertical stretch factor. It's just 1. It stays the same. But horizontally, there's a change. What happens horizontally? Stretched by 3, yeah. So horizontal stretch factor, remember the one I'm dealing with here, its reciprocal is what counts. So 1/3 horizontal stretch factor is 3. Translations, what's going to happen horizontally for a translation? Okay, vertically? Up 4. Okay, so if I was to read this to you and give you a recipe, I would say first reflect it in the x-axis, then do a horizontal stretch by a factor of 3, move it by 5 to the right, and then up by 4. If you do it in that order, you will have a correct graph in front of you. Okay? We'll actually practice some graphs, but I want you to be able to like say it back and forth with me. So I'm going to come around. There's 3 more there. Be careful that you factor. The next 3 you have to factor first. But I'll be coming around to see how we're doing. I want you to work at your desk with your neighbor and see how you do on those. Catch up here. So the first thing you should have had done is a little bit of factoring. Okay, there are no reflections here. Nothing has been changed to a negative, so none to look for. But there is a vertical stretch factor, which is 2. There is a horizontal stretch factor of 1/3. It is moved right by 2. Remember, not the original 6, but 2. And it's moved up by 5. Okay, hands up. Who did it? Okay, good stuff. Again, I'll factor before I even start talking about this one. So -2. And now I have this for my function. So again, you know, if you're wondering, the easiest way to factor is you divide everybody, right? I have to divide everybody by -2. So I have to divide this by -2, and it gives +3. Divide this by -2, and I just get x. Because when you do fractions, it gets weirder, right? How do you factor out the fraction? So when we get there, my advice is that you divide each piece by 1/2. That'll tell you what the factoring was. Okay, both axes here have a reflection. You can see right there, that would be the y-axis reflection. And that would be the x-axis reflection.
Does it matter which one we do first?
Reflections, no. No, it does not. Good question. The vertical stretch factor, there is none in this case. The graph remains the same. But there is a horizontal stretch factor of 1/2. It's going to move left by 3 and up by 1. Okay. And then the last graph here, if I factor that 1/2, yeah, it's going to be a 6 in there. Okay, so most of the math that you're doing in this unit is pretty like, you know, add, subtract, multiply, divide. It's pretty simple stuff, but it's careless mistakes that people get caught in usually. So be careful, that should be x plus 6. There's no reflection happening. The vertical stretch factor is 5. What's the horizontal stretch factor? Yeah, 2. It's double. And I'm going to go 6 to the left and down 7. Excellent. Okay. So I know some of us were doing a quick recap review. All I have to say to you is I apologize that I am going to move this down because I held up the other side of the class for a bit. It's going to go on YouTube tonight if you didn't get all of it right now. Okay, you can catch up to us at this point here. Okay, so now let's go from the English into the f of x notation, the functions. So if I told you I was going to reflect it in the x and y axes, expand it vertically by a factor of 2, and compress it by a factor of 1/3, and then 2 left and 4 down. That's a lot of stuff happening. So we'll go one thing at a time. If we reflect it in the y and the x axes, what happens to it? What does it look like if I do the reflection on both axes? Yeah, there'll be 2 negatives now. It'll look like this. Okay. The next thing, it says I've got to go vertical by a factor of 2. So let's just stop for a second. What needs to change now if I go vertically stretch it by 2? Yeah, there's going to be a 2 in front of it now. Okay, and if I compress it by 1/3, what do I have to do to get 1/3 here? Yeah, it's 3, right? X is kind of strange. Everything's backwards. So if I want to see that graph compressed by 1/3, I have to start with 3, right? And then it says I've got to move it left by 2 units. Sorry, what did I? Oh, I forgot the negative, thank you. I was just testing you. And x plus 2, that moved it to the left 2, and 4 units down. Okay, so this is the graph of the translated function. So I'm going to ask you guys to try the next one. Here's the English expression. See if you can come up with a function to describe it for me. Okay? I'll come around and see how we're doing with it. Some of you might be able to do this all in one shot. Great, that's awesome. I'm not expecting that. Try and do it in little pieces where you can manage. Here's what you should have. I'm going to walk through them in a couple steps at a time. It seems like when I went around, most people were already up to this spot. So I'll make my first step, 5 times for vertically. And I'm going to reflect in the y-axis. So if this is the y-axis and a point is moving across the y-axis, it's the x, it's the x coordinate that's actually changing, right? So it's going to be, that is the reflection, and this is the expansion. So I know that jumped a couple steps, but most people were already up to there. That's why I'm trying to catch up to you. So we should have this as a final. Sorry, I tend to make a lot of mistakes when I rush. Funny how that works, eh? X minus 6 to the right and 3 up. So this should be our final graph, or our final equation to represent that graph. All right. And again, I know some of you that just transferred to the class, you may need to talk about, getting us a little bit extra help to catch up here, but hopefully it's starting to get there. If not, we have the YouTube resource to go on. Okay, locate the point after the transformation. So, what we want to think about here is what's happened to the graph. It's actually not nearly as bad as it looks, okay? Really, I gave you a funny new word today. Math teachers are full of them, like SOHCAHTOA. You guys get to learn CHOSHAKOW. And what did I give you today? Good. Okay, so that's what we're going to do. Whenever we're applying it onto the graph, it's just an easy way to organize yourself. So here's the point, 3, negative 7. Any reflections? So we're still at 3, negative 7. Have any expansions occurred? Okay, someone give me an expansion. Okay, so there's a vertical by 2, that makes this 6. Sorry, there's a vertical by 2, that makes this negative 14. There is also a horizontal by 4, which makes this 12. And in this case, there are no compressions to find. So the last thing we need to do is look at that and ask ourselves, is there any translations? So what are the translations? How does it move the graph? Okay, so right 2 will put me at 14. And up 3 will put me at negative 11. Okay. So that's how I like to do it to keep myself organized. Use that new funny keyword. Try it again with 5 and 2. See where 5 and 2 ends up. Okay, so RECT. Reflections. How many of you did this? Did I catch you? Did I catch you? Did you factor it? Oh, wow, genius. I wasn't trying. Anyways, that's the point I'm trying to illustrate there is just a negative. You got to factor that too, right? Because what's happened is it's moved 4 to the right in the reflected graph. So the reflected graph is actually 4 to the left. Okay, so there is a y-axis reflection, which is going to make this negative 5, 2. Then expansions, there are none. But there is a compression right here. It's a half vertically, so it's going to be negative 5 and 1. And I move 4 to the left. And 1 up. So that's where you should find the point this time on the new graph. Okay? Now, that's enough for you to be able to sketch some graphs, right? Because you just need to apply that to those key points. We're not going to have time to do it today. I'm going to have to put a part 2 on YouTube, I guess. But what we're going to do here is we're going to say, let's see if we can transform the actual equation itself. Okay, this part's a little bit trickier. What time? Sorry, 33? Is that when we? Okay, so I have a little bit of time here. How do you figure out, now that you've got this transformation, how do you actually change the equation? How do you, then update it? So if here's where you started, and this is what I want you to do to the graph, what's the new equation? Okay, that's what we're going to practice. So first of all, we need to know, I call this transformation notation. It's a very useful thing in transformations, but basically what you do is you pull all of the vertical to one side and all the horizontal to the other. So what I mean is I'm going to rewrite this as y plus 3 is 2 f of negative x plus 1. And then I'm going to move this 2 as well, which is also vertical. So I forgot some brackets in there. Now the reason I wanted to do things this way is originally this is what I started with. I started with y equals f of x. Now I have this messy looking awful thing here. But what it tells me is this graph no longer has a y. Now it has a 1/2 y plus 3. And there is no longer an x. There is a negative x plus 1. I can go ahead and directly put that back in the equation to get my answer. This is a mapping on the function. It's saying whatever used to be y, it needs to be changed to 1/2 y plus 3. Whatever used to be x needs to be changed to negative x plus 1. And you'll end up with an equation now that matches your transformation. Okay? So how did I know to pick these? Originally it was a 3. That's vertical. It moves the graph up and down. All the vertical goes to one side. This is a vertical stretch, so I moved it to the other side of the equation. So all the vertical is on this side, and all the horizontal is on the other. So that way, not only can you describe the function and find the transformation, now you can actually get the equation back that's changed. So what would it look like for us? Y is going to become 1/2 y plus 3. And then each of those x's is going to be negative x plus 1 squared. So I could do a little simplifying here if I wanted to, but that's not the point of this unit, right? It's not an algebra unit, it's a graphing one. So if you were to answer that way for me on a test or a quiz, that would be fine unless I said otherwise. If I actually said simplify, then I'd expect a little bit of work there, but that's how you would end up with your new equation. Oops. So this is as much as I could then put it in my graphing calculator at this point, but this is as much as I'll simplify it. Minus 1. Okay, so if I was to put this equation at the bottom here into my graphing calculator, it would be the transformed graph of the original. Is that pretty? No, it's messy, it's yucky. Nobody ever likes talking about transformation notation, but there are going to be some questions in your homework, which we're going to have to postpone, I guess. That's my weekend present to you. Yeah, I know. Well, we're going to run out of time here, but that are going to ask you to say, okay, great. You know how to move a graph. You know how to talk about function notation, but so what? What's the equation look like? So we'll practice this again, I think, but I'm going to pause it here. Look for part 2 when we start on Monday. Don't pack up just yet.